Hello, good morning. I'm discussing sampling in different states. Sampling in different states refers to selecting samples from populations in varying conditions or contexts such as geographical, physical, or operational states. Many of the problems occurring during the sampling arise from the physical nature of the materials to be analyzed. Although gases and liquids create several difficulties, the greatest problems of adequate sampling arise with solids. Types of different state of samplings, and there are mainly three states: sampling of gases, sampling of liquids, solid sampling. Sampling of gases. Difficulties may arise during the sampling of gases if precautions are not taken to clear valves, taps, and connecting pipes for any other gas prior to passage of the sample. Few problems arise over homogeneity of gas mixtures, where the storage vessel is subjected to temperature or pressure variation. The gaseous components should not react with the sampling in analytical device. Atmospheric air contains particulate matter as well as many gaseous compounds. The composition of an air depends on a number of factors like location, temperature, wind, and rain. In the collection of atmospheric sample for analysis, the volume taken and the rate and the duration of sampling are important factors. The air is passed through a series of fine filters to isolate particulate matter and then through a column of a solution where chemical reaction occurs to trap the desired compound. The particulate matter collected in filter is determined by chemical analysis or by weighing. Sampling of liquids. Sampling liquids such as groundwater from wells may involve the use of the specialized downhole sampling device with valves that can be remotely opened and closed. In most of the cases, stirring or mixing is sufficient to ensure homogeneity prior to sampling. Where different phases exist, it is essential to determine the relative volumes of each phase in order to compare the composition one phase with other. If the liquids to be analyzed is homogeneous, the sampling process is straightforward. The process is much more difficult if the liquid is heterogeneous. In case of liquid circulating in like pipe system, samples are often taken from different points in the system. In a lake or river, samples may be taken at different locations and different depths. In testing for the content of contamination in the river, samples may be taken at a number of places downstream from the sewer outlet point where wastewater or sewage exists at sewer system. Devices called grab sampler may be used to collect samples from large bodies of water from river at various depths. Such a device consists of a sample bottle inside a material container sufficiently heavy to force the empty bottle to the desired depth. The sample bottle is closed by a stopper which has a line attached to it and held by person taking the sample. The device is lowered to the desired depth of river. The stopper is pulled out and the sample bottle is filled. The sampler may have a ball float which automatically seals the bottle when it is filled. Types of water samples. Grab samples. A properly taken grab sample is a snapshot of the quality of the water at the exact time and place the sample was taken. Depending on the water body, grab samples may be taken by simply dipping a sample bottle in the water body, or they may require the use of specific sampling device. Grab samples are single samples collected at a specific spot at a site over a short period of time, typically seconds or minutes. Thus, they represent a snapshot in both space and time. Depth-integrated grab samples are collected over a predetermined part or the entire depth of water column at a selected location and time in a given body of water. A sample can represent only the composition of its source at the time and place of collection. However, when a source is unknown to be relatively constant, the composition over an extended time or over a substantial distance in all directions, then the sample may represent a longer time period and or a larger volume than the specific time and place at which it was collected. In such circumstances, a source may be represented adequately by single graph samples. When a source is known to vary with time, graph samples collected at suitable intervals, analyzed separately, can document the extent, frequency, and duration of these variations. Choose sampling intervals on the basis of the expected frequency of changes, which may vary from as little as 5 meters to long as 1 hour or more. Seasonal variation in natural systems may necessitate sampling over months. Okay. Seasonal variation in natural systems may necessitate sampling over months. When the source composition varies in space, that is from location to location rather than time, collect samples from appropriate locations that will meet the objectives of the study, for examples, upstream and downstream from a point source, etc. Composite samples. A composite sample is a mixture of graph samples taken at different times or locations and pooled together to provide one sample. Composite samples should provide a more representative sampling of heterogeneous matrix in which the concentration of the analyte of interest may vary over a short period of time or space. Composite samples can be obtained by combining portions of multiple graph samples or by using a specially designed automatic sampling device. Sequential composite samples are collected by using continuous constant sample pumping or by mixing equal water volumes collected at time intervals. Flow portion composites are collected by continuous at a rate proportional to flow by mixing volume of water collected at time intervals that are inversely proportional to the volume of flow or by mixing volume of water proportional to the flow collected during or at regular time intervals. Advantage Advantage of composite samples include reduced cost of analyzing a large number of samples, more representative samples of heterogeneous matrices, and large sample size when amounts of test samples are limited. Disadvantage Disadvantage of samples include loss of analyte relationship in individual samples, potential dilution of analytes below detection levels, increased potential analytical interference, and increased possibility of analyte interactions. In addition, use of composite samples may reduce the number of samples analyzed below the required statistical need for specified data quality objectives or project-specific objectives. Solid sampling. Modern techniques for solid samples include accelerated solvent extraction, supercritical fluid extraction, microwave-assisted extraction, thermal extraction. In solid liquid extraction, the sample is present in a closed container and a solvent that is able to dissolve the analytes is added. It is with solid that are real difficulties over homogeneity rise. Even materials that superficially appear to be homogeneous may have localized impurities and vary in composition. Sampling is comparatively simple if the sample is homogeneous, but if the material is bulky and heterogeneous, sampling must be carried out with great care, and the methods will vary depending upon the nature of the bulk solids. In this case, select a large number of portions in a systematic manner from different parts of the bulk and then combine them. The first step in the sampling of solid is to select a large portion of the solid materials as a gross sample. After the sample has been selected and grind or crush and systematically mix and reduce size. Mechanical methods exist for dividing up particulate materials into suitably sized sample. A mechanical device for subdividing any sample is called rifle. Further grinding of sample is done by using mortar and pestle. It is expected that final laboratory sample of 1 gram or so is the representative of the gross sample. Okay, it's all about sampling in different state, sampling of gases, sampling of liquids, and solid sampling. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you again.